Hi, Algebra 2 students. Today your learning target is I can solve a linear equation. So let's get started right away. Our first problem we have here is solve 4x minus 7 equals 23. So I'm going to refresh you on this, on how to solve these. You learned how to solve, or you should have learned in algebra and reinforced in geometry. So let's get going. We have 4x minus 7 equals 23. So the first thing that we want to do is we want to get x by itself on this side of the equal sign, right? So we want x by itself on the left side of that equal sign. We want to get all the other numbers to the right side, okay? So if I was in class, I'd say, well, what do we want to get rid of first? The 4 or the minus 7, the negative 7? And we want to get rid of that minus 7, right? So we need to bring it to the other side of the equal sign, okay? And whenever we bring things to the opposite side, we do the opposite operation. So we're going to add 7 to both sides. And when we add 7 to both sides, that cancels out here. And we're left with 4x on the left side, okay? And 23 plus 7 on the right side, which gives us 4x equals 30. Again, now I want to get x by itself on this left side of the equal sign, right? I need x to be by itself. I have a multiplication of 4 over here, and I need to get this 4 to the other side, over to that right side. So I want to do the opposite operation of multiplication, and that is division. So I'm going to divide each side by 4. So I have x is equal to 30 over 4. Now x is by itself on that left side like we wanted, right? Okay, on this left side over here. And we have 30 over 4. Now some of you would be like, oh no, a fraction. Don't worry about it. Just think 30 and 4, what do they have in common? And they have a 2 in common. So we can divide by 2 and divide by 2. And when we do that, we get 15 over 2, or a decimal is okay as well, 7.5. Now I should note a decimal is okay if it is rational, which means 7.5 stops, okay? You don't have a decimal that goes on and on and on and on in any order, an irrational number. So like pi, 3.14, and it just keeps going on and on and on. Okay, so 7.5 is rational, so it stops. You can do that. Let's look at the next problem. Okay, we have 3 times the quantity of x plus 6 plus 2 is equal to 39. So again, I need this x by itself on that left side of the equal sign. But before I can start moving numbers over to the right side over here, so x can be by itself, I need to actually distribute this 3 first to the x and to the 6. And when we distribute, okay, we multiply. So 3 times x is 3x, 3 times 6 is 18. And just make sure that you do not distribute it to the 2. That's a common mistake sometimes. Okay, so once again, I need x by itself on this left side of the equal sign, and I need to get the other numbers to the right. But what I'm going to do first to clean it up a bit is I'm going to combine, I'm going to combine like terms on this left side, okay? I'm going to get this 18 and this 2 together. There's nothing to combine on the right side, so I don't have to worry about that. So 18 plus 2, those are like terms. I add those together and I get 3x plus 20 is equal to 39. And now I am ready to get x by itself. I want to get rid of that 20 and that 3, okay? And I want to get them to the other side of the equal sign. So I'm going to start with that addition of 20. The opposite operation of addition of 20 is subtraction of 20. Okay, so I do that to both sides. That cancels out right there, right? Okay, and now I'm left with 3x is equal to 19. I still need x by itself, right, on this left side over here of the equal sign. I have a multiplication of 3, so what do I need to do? I need to get rid of it by dividing by 3, okay? So that now cancels out, and I am left with x is equal to 19 over 3, okay? So 19 over 3, you can, if you put it in your calculator, it's 6.3 repeating, and that's 6 1/3. But you can leave it as an improper fraction. Many of your teachers would prefer that anyway. They don't like the 6.3 repeating. It's fine. A lot of teachers prefer that improper fraction just so you get used to that, okay? But both are correct answers. The only thing that's important is that you don't write 6.3. Sometimes people write that down instead of 6.3 repeating. That line over it means repeating, and that is incorrect. So just don't do that one. Okay, let's move on. Oops. Cover up my screen here. I have 9 minus 2x is equal to 3 times the quantity of x minus 2. Now, this one's a little bit more difficult because we have x's on both sides, on the left side and the right side of the equal sign. What you should notice first, though, is we have this 3 here with a parentheses, which means we need to distribute it, okay? When we distribute it, we get 9 minus 2x still on that left side, and then 3x minus 6 on the right side. And distributing means to multiply, okay? Now what I want to do is I want to get these variables together, this negative 2x and the 3x. So I need to combine them together. But because they're on opposite sides here, I need to combine them by doing opposite operations. So I have to pick which one I want to bring over to which side. And I'm going to choose to bring this negative 2x over to the right side because then I'll have a positive number that I'm dealing with. Okay, it doesn't matter. You could bring this 3x to the left side as well, but then you're going to have a negative number over here. So I have a subtraction of 2x. I'm going to bring over to the right side. The opposite operation then would be addition of 2x. That cancels this out, and I'm left with 9 is equal to 5x minus 6. Okay, now what I have, okay, is I'm all ready to solve for x. I want to keep x now on this right side. I want to get rid of the subtraction of 6 and the multiplication of 5. And I need to get rid of the subtraction of 6 and bring it to the left side by doing the opposite operation. That's going to cancel that out over here. And I'm left with 5x is equal to 15. Again, I need x by itself on this right side, okay, of the equal sign. And I need to get 5 to the left side by doing the opposite operation. The opposite operation of multiplication of 5 is division of 5. So I'm going to divide each side by 5. And then I'm left with 15 divided by 5, which is 3. X is equal to 3. Now keep in mind, at any point you're wondering, am I doing this right? You can always take what you got for an answer and plug it back into the x values, and you should have an equal or an equivalent statement here. Okay, let's keep moving on. This one, instead of having written out for you, I'm going to actually do with you because of the fractions. I think that that would help some people. So looking at this, I'm going to stay nice and organized, and I am working on my iPad with my pen here, so it looks a little messier than it would in person, but that's okay. We can run with it. Okay, so the first thing on this right side, I want to, oops, sorry about that. I want to distribute this 3. Okay, so I'm going to distribute to the x and to the negative 4. So I have 3x minus 12 plus 3/4. And over on this side, I don't need to do anything. I have a 1/2 and a negative 2x. So 1/2 minus 2x. Okay, so the next thing I want to do, you guys, is I want to actually just go ahead and get rid of the denominators here. Okay, I want to get rid of it because I don't like fractions. So how I'm going to get rid of it is I'm going to teach you a strategy, and that is you think about 1/2 and 3/4. If you're going to add 1/2 and 3/4 together, you would need a common denominator. So we want to think about what would a common denominator be if you're going to add 1/2 and 3/4, and that's going to be 4. And now what I'm going to do with that common denominator is I'm actually going to go ahead and I'm going to multiply each term here that I see, the 1/2, negative 2x, 3x, negative 12, and 3/4 by the common denominator. And what that will do, you guys, is that will get rid of the denominator. So I'm going to go ahead and I'm going to multiply 3/4 times 4. And what I'm going to do with that, there's a bunch of strategies that you can do, but if you struggle at math at all, I think the easiest thing to do is you say, okay, what's 4 times 3, right? 4 times 3 is 12, divided by 4 is 3. So I take that numerator and I multiply it by the common denominator, then I divide by the denominator. Again, numerator times common denominator, divide by denominator. Okay, so 3 times 4 is 12, divided by 4 is 3. Okay, again, I just said I need to multiply each term by the common denominator. So I'm going to do it again right here. Negative 12 times 4 is negative 48. Again, I need to do it here. 3x times 4 is 12x. I need to do it here again, every term. Negative 2x times 4 is negative 8x. And 1/2 times 4, some of you can do that really fast in your head, but let's use that same strategy in case you struggle with math that I just taught you. So I take the numerator times the common denominator, divide by the denominator. 1 times 4 is 4, divided by 2 is 2. Now, if you look in blue here, all of our fractions are gone, and a lot of people now are satisfied with that. So what I want to do next, you guys, is I want to get common terms together on each side of the equal sign. So over here, 2 and negative 8x, I can't get any common terms together because those are not like terms. But right here, negative 48 and 3, I can put that together. So that's going to give me 2 minus 8x equals 12x minus 45. See? Okay, so the next thing I can do now is I can combine my x's together. But remember, because they're on opposite sides, I have to pick one and do an opposite operation. And I'm going to pick that negative 8x, so I'm going to add 8x. So I now have 2 is equal to 20x minus 45. Okay, now I'm ready to get x all by itself. So I'm going to add 45. That gives me 47 is equal to 20x. I'm going to divide by 20. Okay, and when I divide by 20, I have 47 divided by 20. And that's going to give me 2.35. And again, that stops there. That has a decimal that stops. It doesn't go on and on and on. Okay, so you can use that as an answer. That is fine, 2.35. Okay, let's move on to the next problem. Hopefully that gave you a good strategy for using fractions. Again, don't worry if you're still a little uncomfortable. A lot of times it takes a while for people to practice with fractions to get comfortable. Before we move on to the next slide, I do want to be really clear though about one thing. I'll just kind of make up a problem on the fly. With fractions, let's say that I had 1/3 x plus 5 equals 10. Okay. In this case, you could use that strategy I just talked to you about as a common denominator, but it really, in my opinion, I only use it when there's more than one fraction. Okay, when there's just one fraction like this with the variable, okay, then this is just another thing, and I just want to show you all the different ways. In this case, when I get rid of that 1/3, I'm just going to do the multiplying of the reciprocal. So some of you have learned that before. So I subtract 5 here. And that gives me 1/3 x equals 5. And now to get rid of that multiplication of 1/3, we do divide by 1/3. But when we divide a fraction, it's actually multiplying by the reciprocal. Okay, so that gets rid of it. And I multiply by the reciprocal over here. And I get x is equal to 15. Now, you could have used the strategy I just showed you by multiplying everything by the common denominator. Well, since I only have 1/3 here, I would multiply by 3. And just ask your teacher if you want your teacher to practice that with you more. Okay, let's finish up here. A couple unique situations. So I have this problem here, 3 times the quantity of x plus 7 is equal to x plus 4 plus 2x plus 6. So what I did is I distributed and I combined terms over on this right side and distributed on the left side. When I did that, I got 3x plus 21 is equal to 3x. Now, some of you know what happens right away, but let me talk through it in case you don't. I combine my x's right now by doing opposite operations. Well, they're the same, doesn't matter which one I pick, so I subtracted 3x. Well, what you'll notice is then these both cancel. And I'm left with 21 is equal to 10, and that is not a correct statement. So when something like that happens, that's called no solution. Okay, and finally, one other unique situation that does happen. When I have 4 times the quantity of x minus 3 plus 2 equals 2x minus 12 plus 2x plus 2. Again, I distributed and combined like terms over here to get 4x minus 12 plus 2 is equal to 4x minus 10. I then combine my like terms over here on the left side. That gives me 4x minus 10 is equal to 4x minus 10. Some of you again know what the answer is going to be, but let me just talk through it real quick. I'm going to combine these variables, these 4x's, and when I subtract 4x, I'm left with negative 10 is equal to negative 10. And that means we have all real solutions for our answer. So all real solutions, okay, for our answer. Okay, guys, that is it for the day. Again, this was a refresher. I hope to refresh your skills on solving linear equations, and make sure you bring any questions that you have to your teacher, and they can further clarify things for you if you need. Have a great day.